What is going on, guys? It is time for another episode of our Java OpenGL 2D game development tutorial series. Okay, in this episode, we're going to create a simple mouse looking for our test player. The type of game that we're going to be working on here is going to be a basic top-down shooter style, because it'll allow us to cover a lot of the basic elements of game design. So, if you remember from last time, we were able to control our player using the up, down, left, and right keys on the keyboard. The first thing we're going to do is we're going to go to the test player. Where did I put it? org.test. There it is. Test player. And we're going to change the keys to A instead of left, D instead of right, W instead of up, and S instead of down, because that's a more standard video game control. Yep, there we go. More standard video game control setup using W, A, S, and D instead of up, down, left, and right. So what we're going to do, the way we make it look at the mouse is we're going to need to do a combination of different things. We're going to need to rotate it. And in order to rotate, we obviously, the game object already has, if you were to go into the game object class, it already has a rotation. It has a rotation variable that we can use to rotate the object. But we're going to need to get the mouse position first. That's the first thing we have to do. So we're going to go into our input package and find our mouse input class. And what we're going to do is we're going to create a couple of static variables. I'm going to call it private static int x equals 0, private static int y equals 0. And these are basically going to be the x and y positions in the window of the mouse input. And then we're going to need to do public static int get x, simply return x. And a public static int get y, for that we return y. And now we actually have to set these variables to something. And we do that in the mouse moved method, which you should have the method stub already in here from whenever we created the mouse input. It's the one called mouse moved. That basically means when the mouse was moved in the window, we get an event. And we say we say x is equal to e.getX. Like that. And y is equal to e.getY. So that means that the pixel position of the mouse, anytime the mouse is moved, is going to be sent to the x and y. If the mouse holds still, it'll just stay whatever the last movement was set to, what the x and y were set to, it'll just stay on that. So we don't have to worry if the mouse is holding still. So from this, we can't necessarily get everything working yet. And some of you probably already know why. And the reason is our OpenGL coordinate system is based on a system of units that we predefined to make things easier for us to work with and to be able to make our game resolution independent. But the x and y coordinates that we get from this mouse moved function, and therefore our x and y coordinates up here, and what we return with our getX and getY methods here, these are all going to be relative to the window, and they're all going to be x and y as far as pixel coordinates are concerned. I probably could have phrased that better. But basically, x and y are going to be pixels relative to the window, and this is not good because our player needs to look at a position in our virtual world space, not a position in pixel space, because that doesn't make sense for our purposes. So we need to find a way to convert the x and y into world space. And for this, since we will sometimes want to get the x and y position of the mouse in actual pixel coordinates, like for example, when we eventually replace the cursor with like a crosshair or something like that, we're going to want it drawn in an absolute position on the screen. And so what we need to do is create two new methods, public static float, since our world coordinates are measured in floats, get world x, and then a public static float get world y. Now, we need to find a way to convert pixel coordinates to world coordinates. And so I'm going to do that on the fly here, and hope I get it right. I did this before. Like I said, a lot of the code, I know how to do it because I did it a long time ago when I wrote a game engine that I used to make a couple of games, but I haven't written it in a long time. I know it works because I did it then, so hopefully I can remember how I did it. So to get the world x, we simply want to return a value that is, we don't really need these parentheses, but I'm putting them in here because it helps to keep everything organized. Let me get rid of them. Alright, it's basically going to be, we need renderer dot units wide divided by renderer dot get window width. That this is in pixels, just so you know. Units wide, if you remember, is how many units wide the game is, basically. And then renderer.get window width, if we divide units wide by window width, we're getting basically 1 pixel's worth of units, if that makes sense. And we basically want to multiply that by x. And what this means basically is this should hopefully convert the values. To test to see if it does actually convert the values the way we want it to, first off, in get world y, we're just going to say return 0 for the moment, because we want to get rid of that error so we can test this. Then I'm going to go into the test player class. I'm going to tell it system.out.println mouse input dot get world x. Now, in our renderer class, we said that units wide is 10. So that means 0 should be, or actually I think since because of the way it's positioned, this should be -5, I think. And then this is +5. I'm not completely sure. Either way, let's see what happens when we run the game. And I move my mouse all the way to the left and leave it there. Move it around a bit. Move it all the way to the right. We quit. What did we get? We got zeros. Everything is a 0. Okay. Why did we get zeros? Okay. Back in mouse input. Units wide divided by get window width multiplied by x. Okay, what if instead I just told it to return x? This will obviously be pixel coordinates. So I move it over here. I move it over here. And what do we get? All zeros. Why are we getting zeros? We are using get world x. For some reason we're getting zeros. What would be the reason for that? Everything is a 0. Okay, wait a second. I might have to click in the window. I forgot about the get focus thing not working. Okay, false alarm. For a second I thought something went horribly wrong. I mean, it did go wrong, but not horribly wrong at least. Only sort of wrong. So we go to the left and to the right. And we quit. And we're still getting zeros. Okay, maybe I don't know what I'm doing. Wait, click. Move to the left. Move to the right. Okay. I do know what I'm doing. I forgot to click that first time. Bear with me, please. Okay, so yeah, 0 is on the far left, and then as you can see, when I moved it over to the right, we quickly jumped up to 9.99, effectively 10, but it's rounded off because of the imprecision of floats. Or rather, it's not rounded off. I'm rounding it off for our purposes. It's 10. So that means that we have successfully converted one type of unit to the other. Except, because of the way we are using our coordinates at the moment, right now we're basically saying that 0 is over here on the left, and units wide, number of units, in this case 10 units, is all the way to the right. But that's not the way our game is actually working, as you know by the fact that whenever we drew, or whenever we create the player in the main method, where is it? Here. It says new test player. Okay, so test player is a game object, and the game object class x and y are 0 by default. Well, if they're 0, if x of 0, according to our little mouse function, is over here, y is 0 on the x-axis in the middle. And that's because of the way we are using our coordinates. I mean, it's just the way we did the math just now. What we really should be doing is everything should be offset by the position of an imaginary camera. And it's going to be a long video if I go ahead and implement the camera system now. Okay, well, might as well get started. We're going to implement the camera system now, and it's going to be, the best place for it's going to be in our renderer class. I'm going to have a public static float camera x equals 0, and a public static float camera y equals 0. And so, the camera, it's really just a rendering thing. So the only time we actually need to take the camera into account is when we are rendering things. And so the easiest way to do that is to tell everything to draw exactly where it is and everything, but before we draw every frame, offset the OpenGL context by the camera's values. So, for example, for testing purposes, we'll say that the camera's x is equal to 1. In other words, the camera is 1 unit to the right. And this means everything else should appear to be drawn 1 unit to the left relative to the screen, if that makes sense. Now let's do 2 units to make sure everything moves far enough for us to be able to tell that we've gotten it correct. So if we go into graphics, no, renderer. Yeah, renderer is right. We got window.display. Okay, so it's event listener. At the beginning of the display, before we call world.render, we're going to say gl.glTranslate f. The x is going to be negative renderer.cameraX. The y is going to be negative renderer.camera-y, and the z is going to be 0. And then at the end, gl.glTranslate f, the opposite of that, renderer.cameraX instead of negative, renderer.camera-y, and 0 again. So, why negative? Well, because basically what happens is, in order to make, and this is one of the biggest illusions in video games, is the illusion that there is a camera. There's no camera. All a camera really is an arbitrary set of values that determine the way you draw everything else. Really, there's no camera or anything like that. When we move the camera to the right, what we're really doing is telling everything else to be drawn further to the left. That's why we're subtracting the camera's position. We say if the camera's x is 2, everything else should be minus 2 from wherever it is. So that's the big illusion in video games, and once you understand that, especially in 3D games, it's very enlightening, because it's like all of a sudden you realize that your camera is not moving through the world is moving around the camera. And it's a very weird thing to grasp at first, but once you get that, graphics in video games, the whole concept of writing graphics for video games just becomes so much simpler, in my opinion. Maybe I'm the only one who had difficulty understanding that at first, or who thought that was the weirdest thing whenever I first found it out. But basically, once you understand that, it makes things so much easier. So basically, if we start the game now, everything should be drawn 2 units to the left. Yes, it is 2 units to the left. So if, for example, in the test player, if I told it, if I said, okay, if I said, what do I want to do here? Let's say renderer.cameraX plus equals 1.0f times game loop dot update delta. It should move the camera 1 unit to the right every second. So you'll really see what's going on. And so you see how that worked. Now I'm trying to move back in, and you see I'm moving around here. If I'm moving up and down, the camera's moving away from me. So yeah, that's just to test our camera system. So, back to getting the mouse input relative to the camera. What we need to do is we need to go back into the main method, the renderer, set the camera to 0. Sorry I'm jumping around so much in this. This is kind of an interconnected episode because we're doing a lot of different things. But going into mouse input, what we need to do is we need to offset this by the camera. Now, since 0 is the center of the camera, basically, then we can't use this. What we need to do is we need to subtract half of units wide from this whole value, from all of this right here. Actually, you won't even need to do, you won't even need to put parentheses just at the end. Subtract renderer.units wide divided by 2. And that should offset everything by the window width. So over here we should be getting -5, and over here we should be getting +5. Okay, never mind, we get the opposite. Why do we get the opposite? Hang on a second. I forgot to click in the window. -5, +5. And yes, we got -5, and we move over to 4.99, which is basically 5. Okay, so next we need to offset this value by the camera's position in order for it to really be accurate. And so what we need to do for that is take all of this, and as far as I know, we simply subtract renderer.camera_x from all of that, and that should result in an offset position. So if we go into renderer and add 1 to x, then since we're moved over, okay, I think actually, now that I think about it, we do not subtract. We add in mouse input, add renderer.camera_x. So if the camera is moved over 1 unit to the right, in other words, x is equal to 1, then over here should now be -4, and over here it should be +6. So let's test it. -4 is right, and +5.99, so basically 6. Okay, this is going to be a long episode. I hope you all hope you've got something to drink, because we're going to be here a while until we get this right. Everything's working so far. I mean, it's not that we're getting anything wrong, it's just that it's taking a while just to get the mouse look done. I probably should have split this into 2 episodes, camera input and then mouse look, but you get a bonus this time. Now, the reason why we're going to have to do something else slightly different for the height is because units wide does not exist. Units height, units tall, whatever you want to call it, does not exist. Units wide does, because we decided that width was our priority, and in order to determine how large everything is drawn on the screen, we use the units wide. So in order to get units height, we need to calculate this based on the ratio of width to height. So units wide is going to be basically, you'll catch on. It's not difficult. Basically, for get world y, we're going to return renderer.units. Let's just say return units tall divided by renderer.getWindowHeight times y minus units tall divided by 2 plus renderer dot camera y. So it's basically the same thing we have up here, except window height instead of window width, y instead of x, and something called units tall instead of units wide. We're going to make our units tall right here. Float units tall is equal to units wide times the ratio of width to height. So the ratio of width to height is going to be renderer dot get window height divided by renderer dot get window width. And actually, though, we're going to have to turn both of these into floats, or else it's not going to work. And make sure we know this is a float. Oh, sorry, that's not how you cast float. I know I'm probably redundant with the casts here, but I want to make absolutely sure it works. And this is renderer.unitsWide, not just units wide. So basically, it's the units wide times the ratio of width and height. At least I think I got that right. I'm really not sure. I guess we'll find out. Basically, this value should be less than units wide, unless you've got a weird screen that's taller than it is wide. So we're going to change in the test player, change our system.out.println to print out the getWorldY value instead of getWorldX. And so we'll test it out from up here and down here. And we should get a positive and negative of the same value. We get negative 3.125, and then we get 3.11, blah, blah, blah. It kind of rounds off. The reason, okay, hang on, why is it negative when we're up high? As long as it's consistent with the way our coordinate system worked for positions, that we shouldn't have a problem. Where are we here? Test player. Okay, so y input plus plus when we move up. Okay, yeah, so because of the way the mouse coordinates work, we need to return the negative of this. For getWorldY, we return the negative of our value there. So when we run this, up here we get a certain thing, and down here we get a certain thing. Yes, good. Now we're getting positive when we're up high and negative when we're down low. Okay, so we're actually getting world position coordinates, I think, which means we can finally use the mouse look. Now to do the mouse look, this is what we've been waiting for this whole episode. We need to say rotation equals angle. Well, actually, I was going to say we could define an angle variable, but we might as well just define the rotation variable. Rotation is equal to math dot arctangent 2 of the mouse position, which is going to be mouse input dot get world x, and mouse input dot get world y. I think. I might be completely wrong about that. Cannot convert from double to float. Okay. Float. And let's try it. No, failure. Why? Oh, because it's probably in radians. You gotta turn this into radians. Degrees. Our rotation is measured in degrees, but this function returns a rotation in radians. So we need multiply it by math dot, where is it? Math dot, what was it called? Why can't I remember it? Oh, okay. I'm thinking of Unity. Okay. Yeah, don't do this. In Unity, it's different. But basically, we're going to say math dot 2 radians, 2 degrees. Inside of those parentheses, we put the atan2 function. We run it, and you might have to click in the window like I just did to make sure it responds, but you'll notice that our Nicolas Cage picture is now following the mouse. I feel so proud for some reason, just because of how long that took, even though I've done this before. But if you've done this, you should be proud of yourself because you just did a bunch of maths and you made something very interesting happen. Our game is now more interactive. Now, something you will notice, when we move like this, we have a problem. He's not looking at the mouse. That's because our position, or this arctangent thing, only works when your position is 0. So we're going to do something very similar to what we did with the camera, where we subtracted the camera's position. We're just going to, for the mouse input.getWorldX and mouse input.getWorldY, all we got to do is offset it by subtracting our x and subtracting our y from getWorldX and getWorldY. And that should solve the problem. So he's looking at the mouse like this, and then when I move, he's still looking at the mouse. So I can move around like this, and we've got the basics of our top-down shooter. So guys, thank you for watching this episode. I know it was very long. We covered quite a bit of material here, and we're on our way to making our game into an actual game, which will be so excited when we finally get to actually make a game out of all of this. Thank you very much for watching. I hope it wasn't too long. It might take a while for me to upload this one because of how long it is, so bear with me, and I apologize for this episode being late. So, if you liked the video, don't forget to like. If you have any questions, leave comments. I would love to read the comments, and I'll do my best to answer them. Subscribe to stay up to date when I put up new videos, which ideally is every Monday through Friday. And once again, thank you very much for watching, and I will see you in the next video.